Hello class, welcome to another lesson. Today's lesson is on bar models. Please make sure you're taking notes. Here we have equivalent ratios have the same ratio in simplest form. So P to Q is 1 to 2, and we have that shown with bar models. So R to S is 2 to 4, and we can reduce that by dividing by 2. And so we can see that it also is the same as 1 to 2. Right? So two ratios are equivalent when each ratio can be expressed as the same ratio in simplest form. Please make sure you write this down. The ratios 1 to 2 and 2 to 4 are equivalent ratios. Each ratio can be expressed in simplest form as 1 to 2, so these two are equivalent. Right? So part B says, are ratios 3 to 4 and 6 to 9 equivalent? Well, 3 to 4 is in simplest form, and 6 to 9 we can reduce to 2 to 3. So we do this by dividing each term by the greatest common factor, which is 3. And so 3 to 4 and 2 to 3 are not the same ratio. Okay, let's try another slide. Here's a word problem. Megan prepares a fruit punch using apple juice and orange juice in the ratio 4 to 3. So this is apple, label it, and this is orange juice, right? So if the total volume of fruit punch is 630 milliliters between 4 to 3, find the volume of apple juice Megan uses. So here's a bar model that shows apple juice is 4 and orange juice is 3, and we know the total volume of fruit punch is 630, which is why it's labeled for all of them, right? So this is how we find what each unit is. The volume of apple juice to the volume of orange juice is 4 to 3, so we know the total volume is 7 units, right, as shown in the bar model. So 7 units is equal to 630. So therefore then if we divide by 7, because there's 7 pieces, then each one of these units is going to be worth 90 milliliters. So we write that down. We can write them in all of them. And so this is 90, this is 90, this is 90, 90, 90, 90, 90, right? So then 4 units, which is for the apple juice, 4 times 90, as shown here, is equal to 360 milliliters. So Megan uses 360 milliliters of apple juice. Okay, let's try another problem. So a box contains baseball and football cards. The number of baseball cards to the number of football cards is in the ratio 5 to 1. If the total number of cards is 1,380, find the number of each type of cards. Well, we draw it out because we know that the number of baseball cards to the number of football cards is 5 to 1. So we have to figure out what we need to divide this by. So if the total number of cards is 1,380, we know we need to divide it by 1, 2, 3, 4, 5, 6. We need to divide this by 6. So let's do our math over here, and you should be doing this in your notebook. We divide by 6. Doesn't go into 1, it goes into 13 twice. That's 12. We subtract, we get 1. Bring down our 8. 6 goes into 18 3 times. 6 times 3 is 18. We subtract, we get 0, bring down our other 0, and this is 230. So each one of these boxes is worth 230. And you can either choose to write it, in all of them or just write it in one of them, but you need to know that each unit is worth 230. Okay? And so there's 230 football cards, and how do we find how many baseball cards there are? Well, we need to multiply. So we multiply by how many units there are, and there's 5 of them. Each of them is worth 230 times 5. 0 times 5 is 0. 3 times 5 is 15. 2 times 5 is 10, plus 1, that's 11. And so there are 1,150 baseball cards. All right, let's try another. If a school raised $18,000 at a charity event, the money raised was shared among 3 charities, A, B, and C, in the ratio 1 to 3. How much money did each charity receive? Well, we know the total number of units is 1 plus 2 plus 3, We can even write that in. And that's 3 and that's 6, right? And we should have it in a picture over here. You should always draw a bar model. Okay, and so 6 units are equal to $18,000. So what is each unit worth? Well, 18,000 divided by 6 units is what? 18,000 divided by 6. This is 3, and it looks like it'll be 3,000, right? So each unit, the number is too big, so I'm going to draw an arrow. Each unit is worth 3,000 here, and so 6 units, we can say 6 units are worth 18,000. And therefore 1 unit is 18,000 divided by 6, which equals 3,000. And therefore Charity A received 3,000. Charity B received 6,000 because there's 2 units, and Charity C received 9,000 because there are 3 units. Okay? So here's another. Claire keeps some green and red plates in a cabinet. The ratio of the number of green plates to the number of red plates is 2 to 1, and that's shown in the bar model down here. She adds 18 more red plates in the cabinet, and the ratio becomes 4 to 5. Okay, so here's the ratio before, right? The ratio before was 2 to 1. And so we can also say that the ratio, I'm going to split this into 2, the ratio also, I'm going to split this into 2 also. The ratio can also be 1, 2, 3, 4 to 2. Okay, and here's continued on the next slide is the rest of the problem. Here's the after. The ratio of the green plates to the number of red plates becomes 4 to 5, right? So it becomes 4 to 5. The length of the model for blank plates does not change. The model for blank plates is divided into blank units. Okay, so the length for green plates, green does not change. And the model for red plates is divided into 5 units. The model for red plates is divided into units of the same size, and additional units are added to make the total length 5 units. The additional units represent the blank red plates Claire adds into the cabinet. So it's 18 extra red plates right here. 18 extra red plates. And so this is how it's 4 to 5. Okay? A little tricky, but try your best to get it. If you need to, please make sure you re-watch this section of the video. Okay, so if the ratio of the weight of a bear, cow, and a cat is 18 to 17 to 2, if the cat weighs 20 pounds, what is the weight of the bear? Okay, so you need to make sure you label. So I'm going to label bear to cow, has to be in the right order, right? To cat is 18 to 17 to 2. So if the cat weighs 20 pounds, right, what is the weight of the bear? Well, we know to get from 2 to 20, we need to multiply by 10. And so we also need to multiply this by 10, because we will only want to know the weight of the bear. We don't care about the weight of the cow. So then the weight of the bear is 18 times 10 is 180. So the weight of the bear is 180 pounds. Okay? Let's try another. Here's your turn. The ratio of the weight of a tiger, panda, and monkey is 5 to 2 to 1. If the monkey weighs 15 pounds, what is the weight of the tiger? Okay? Please make sure you pause and try this first problem. Here's the second one. The ratio of the weight of a candy bar, a Twizzler, and a gumball is 3 to 2 to 2. If the Twizzler weighs 8 grams, what is the weight of the candy bar? Okay, here's another one. At a charity function, $150,045 was donated by 3 companies, A, B, and C, in the ratio 7 to 5 to 9. How much money did company A donate? Remember to make a bar model. The ratio of the weight of a dog, coyote, and human is 4 to 5 to 8. If the dog weighs 24 pounds, what is the weight of the coyote? Okay, remember again, bar model or equivalent ratios. And here's the last one. At a charity function, $250,000 was donated by 3 companies, A, B, and C, in the ratio of 5 to 6 to 9. How much money did company B donate? Okay, and I will see you tomorrow.